Hello, we are going to quickly be going over the Chapter 3 study guide. This is going to be fast-paced. I won't go through everything, but I will drop a few notes here and there. So we're going to start off with the second half, because that's what we're going to be doing the second half, if I didn't say that already. Starting off with number 7, find any extrema or points of inflection for this function. So we're going to start off as normal, find f prime of x, which in this case is x cubed minus 8. When we set it equal to 0, we find that we get a critical number of 2. So we get x equals 2. And when we plug our critical number back into our first function to find a y value, we find a value of negative 12. So we have a critical point at 2, negative 12. We're going to be finding whether this is a max or a min, so we're going to be checking our intervals. So we have negative infinity to 2 and negative 2 to infinity. We find that this interval is negative and this interval is positive, which means that this must be a min. Now to check for any points of inflection, what we're going to do, let me separate this here. We're going to find our second derivative, f double prime of x, which in this case is 3x squared. Finding where that equals 0, 3x squared equals 0. We find that x equals 0, meaning that at x equals 0, there is no concavity. Let us note, this does not mean that there's actually an inflection point. All this means is that at x equals 0, there is no concavity. An inflection point is where concavity changes, and we're going to be checking if concavity changes with intervals. So since we have x equals 0 and only x equals 0, our intervals are going to be negative infinity to 0 and 0 to positive infinity. When we plug in testing values for each of these, we find that for our first interval, we get a positive value, and for our second interval, we also get a positive value, meaning that there actually is no inflection point. Now you might be asking, well, how does that make any sense? Well, when you have a function like x squared, this is the best example that I can think of, and the graph looks something like this. That's my attempt at a parabola. It's always kind of opening up. It's always opening up. That's why it's always concave up. When you solve for f double prime of x, you just get a constant that's positive. It's always opening up. However, when you get something like x to the 4th power, that'll look something a bit more like this. Let me try that again. It looks a bit more like this. You'll notice that in like this area, right? This area, it flattens out. It flattens out. And on a graph, if you just put f of x equals x to the 4th, that happens at x equals 0. Now, for any straight line, no matter whether it's vertical or horizontal or diagonal, any straight line doesn't have any concavity. And right here, you'll see like noticeably it flattens when it hits 0. This, sure, it flattens. The slope does equal 0, but it immediately goes back up. This is just kind of flattens a lot. So it doesn't have any particular point where the concavity is positive or whether it's negative. It's just a flat line. So because of that, the concavity equals 0. But when you check on both sides, if you plug in x values to this f double prime of x equation, if you plug in x values on both sides, negative and positive, you'll get positive answers. So the graph itself is still concave up. It's just that at the point, at the vertex right here, at the point x equals 0, there's no concavity. To be honest, I'm not really even sure that you'd call it a vertex because it kind of flattens out. But I'm sure you get what I'm trying to say. So while there is no concavity there isn't actually an inflection point because concavity doesn't change. It's always still up like a cup. So that's why there isn't an inflection point. Though we do have our minimum of 2 comma negative 12. Okay, we are going to quickly go over problem 15 here, as it was these type of problems were challenging for me before. So we have our word problem right here, and we have 2 steps. We want to find the amount of money the company should spend on advertising to yield a maximum profit, and what is the maximum profit. Now, the equation that we're given is P of X equals negative 1 over 10 x cubed plus 6x squared plus 400. Now the first step is to find the derivative. Since this negative 1 over 10 is just a constant, we don't have to worry about that really. All we have to do is we can just solve for the derivative of x cubed, which is 3x squared, and then we can multiply that by negative 1 and put that over 10. So since we know, which I know it's a lot of words, it's kind of a mouthful, but let me explain. If the derivative of x cubed is equal to 3x squared, right? And this is a constant. It doesn't have an x value in it, it's just multiplying the x cubed. That'd be the equivalent as having negative 1 over 10 times 3x cubed, which would just put that over 1, it's the same thing. When you multiply those together, you get negative 3x cubed over 10, which we can keep it that way. And then moving on to the next one, we have 6x squared, which is just 12x, and 400 is just 0. So we have our derivative right now. From this point, what we have to do is set it equal to 0, which in this case, it's kind of a long process, but if we go through it, we will find that, I'm going to speed up my work here. So we find that x equals 40. And this is the answer for number A. Although we find an x value of 40, it does note how we're looking for in thousands of dollars. So if we just multiply 40 by 1,000, we get 40,000, which is our answer for A. Our answer for B is all we got to do now is plug in our x value of 40 into the first equation, which is this equation. And when you plug in for P of 40, you get an answer of 3,600, which when multiplied by 1,000 results in an answer of 3.6 million. So that's how to solve problems like that. And yeah.